Okay. This is such an honor for us to present in front of many talented people. Thank you for sharing this precious time with us. Today, I'll make a presentation with him. We are not so fluent in English, but we will do our best. And if you have any questions, please raise your hand. But please note that you ask us slowly, loudly, clearly, with easy words. Okay. At first, let us introduce ourselves. My name is Kiwamu Kato. Just call me Kiwamu. I majored in civil engineering in my university, but I have enhanced and maintained messaging middleware in our company. Sorry? Louder? Sorry. I started Ruby last year, and I have worked as a leader of the AP4R team. This URL is my blog, but most entries are written in Japanese. Sorry. And I don't mean to be too personal, but I'm the first man of marriage. Thank you.
Is it okay? My name is Shunichi Shinohara. Call me Shino. I am a programmer. I love coding. The language of the year is C or Haskell. I made a debut to the open source world last year with AP4R. The URL is my blog. And also I'm interested in physics, especially in the string theory. Thank you.
Okay. And let us show you our corporate profile a little. We work for Future Architect in Japan, and our mission is the optimization and synergy of client business and IT. Our company is located at Tokyo, and we recently moved to new office. Here is some pictures of our office. This is an entrance. It's like a jungle. And there is a Japanese-style meeting room. We have a lunch or use for small meetings sometimes here. And this is a bar. We sometimes drink here. We sometimes drink there. Okay. We work in this office. Well, here is today's agenda. First of all, we will talk about overview of AP4R. The part is very important. We want you to listen to this overview very carefully. After talking an overview, we will talk about details in each feature, such as lightweight, robust, and so on. Also, we will show you a demonstration after this lightweight topic. And finally, we will finish off with the conclusion. Part 1, overview. We will talk about following topics in the overview. What is AP4R? This is a very simple but essential question. And we will give you some typical use cases of AP4R so that you can get image of AP4R more clearly. And then we focus on the advantages of AP4R. And finally, introduce some case examples in real world. What is AP4R? A simple answer is this is a messaging library by Ruby. AP4R stands for Asynchronous Processing for Ruby. By use of messaging, we can execute our task asynchronously and make a loosely coupled system which has some advantages from a high availability and scalability point of view. By the way, before going to the AP4R use case, I'd like to talk about the background why we started AP4R. Our company has developed own messaging library for about 10 years. It's named RTFA. RTFA is written in Java and has a proprietary protocol and API, which are different from JMS. During about 10 years, RTFA has been introduced into various systems, maybe more than 100 systems. This article is one of illustrated cases of RTFA. This is only in Japanese, but now I will give you a little introduction. We developed a mission-critical system in transportation business. The system is processing over 100 million package data per day, and parallel processing and load distribution. Transaction volume is growing day by day. We used approximately 100 servers and RTFA. So our company has leading on the strengths of messaging know-how. As you know, the recent fashion is from Java to Ruby. The right one is the Japanese edition, which is translated by Mr. Kakuntani. He's sitting there. Thank you. We developed AP4R based on experiences of RTFA. We carefully designed to keep good concepts and add some new concepts such as agility. In addition, we focused on ease of use of API and configuration. We released AP4R as an open source with MIT license last year. We want to let AP4R growing in the community instead of a proprietary relationship between user and the provider. By doing this, we can bring up a better one. Moreover, we'd like to apply AP4R to enterprise fields. In the most of enterprise systems, batch processing or delayed tasks are much familiar. By use of messaging, we can improve system usability and flexibility in a complicated system such as mission critical and enterprise system. Next, what are typical use cases of RTFA? The short answer is quicker response to users and load distribution. I will explain them with a simple example. First of all, quicker response to users. If a quick response is not necessary, execute it later. This is a simple system which has a client and a server. We assume that there are some sequential tasks. Users have to wait for a long time until all tasks are down. But usually, the users are not necessary to wait until all tasks are down. Some tasks are not related to the response to the user. So it's possible to separate some tasks asynchronously. Here is a better solution. We assume that only task A and B are necessary for the response to users. The other tasks, C, D, and E, are possible to be executed later. On the first server, task A and B are executed, and then a message is sent to the messaging service. The user can get a response quicker because of the only existence of A and B. Via the messaging service, the message is sent to other or same server, and then the other tasks are executed asynchronously. These are several typical cases: logging, sending mail, and creating heavy summary data. there still have many other things too. In case of blog system, flagback and update index, and so on. One of the advanced cases is inter-system connection. By use of a messaging service, we can develop a loosely coupled system which has a little effect on each application. It leads to a high availability. Next, I'll talk about another use case. It's load distribution. If the higher throughput is required, the system can easily scale out by appropriately adding servers depending on the load. There are some solutions that also use messaging service in the world. Of course, we can do this. Of course, we can do this by using other messaging library. So, what are AP4R's advantages? It's lightweight and robust. I'm going to explain each advantage. So, what is lightweight? It's Ruby. As you know, Ruby has a great advantage: dynamic, succinct, open class, or easy metaprogramming, and so on. Thanks to Ruby, we could focus on ease of use and all-in-one support. As ease of use, we realized a simple API and configuration and seamless collaboration with Rails. Moreover, we supported smooth test and operation. So, one of the advantages is lightweight. Next, what is robust? AP4R guarantees a message delivery. If message deliveries are not guaranteed, it may cause message loss or message duplication. In other words, so if you order some items at online store, you can't receive the item despite payment, or you might be charged twice. This is so sad. So, message should be delivered in a reliable way. No matter what happens, for example, database and network trouble, or server down, busy timeout, and so on. The other advantage is robust. Now, you know for certain that AP4R is lightweight and robust. Each advantage is supported by various features. As a lightweight feature, there are simple API and flexible system design. And as a robust, sub-function and recovery, and so on. More information will follow. But before going to the details, let me talk about some case examples. Here are two case examples. At first, an online game. It is from England. This is a massively multiplayer web-based strategy game, and now in late alpha version, with plans to go into private beta testing next January. They use AP4R in various parts. For example, mail sending, report generation, and data analysis routines. In addition to them, there is a variety of processor-intensive processes that are updating, creating, and destroying thousands of database loads. They have two dedicated AP4 servers, which are collectively dealing with a few hundred messages an hour. They use 4 Rails processes per AP4R and use MySQL as message database. I'm looking forward to seeing the game next year. The other case example is interactivemedium.com. Here is its top page. It's from the United States. And they provide mobile messaging solutions for clients, as well as internal products like Text Me for Business. URL is following. The service has already been in production since this July. Visit textmeforbusiness.com for more information. They use AP4R for inter-system connection and text processing. There are 3 AP4R processes running to process inbound message, to process outbound message, and to handle routing of message to third-party clients. Here is a simplified illustration. AP4R accepts messages from mobile carriers and processes text, and then deliver back a message to the users. Otherwise, routes the message to third-party clients. AP4R is used as a connection part between services, like Enterprise Service Bus. As I just said, interactivemedium.com uses 3 AP4R processes. Besides that, they use 4 Mongolet clusters and 2 daemons to execute some tasks and throw out messages like a scheduler. Now, at least 1,000 messages a day. And they also use MySQL to perpetuate messages. Before we are coming to this RubyConf, we sent out a questionnaire to AP4R users. We got some answers. I'll show you the small portion of them here. Why did they choose AP4R? We were very interested to hear the answer to this question. The answer is AP4R is easy to distribute a kind of load across a number of servers. AP4R is easy to scale. The development is active. The development team has a real-world experience with the technology. These words have really made our day. So, this was the last of overview. We will move on to some details of AP4R advantages. But before moving on to the next, let's take a coffee break. I'll talk about a mascot. You know, it is Firefox. And it is Fokusuke. Do you know? Is it only in Japan? I think this one is more cute. And Java is Duke. Is it cute, isn't it? Anyway, a lot of software in the world have a cute and attractive mascot. So, mascot matters. Then, AP4R is this. How do you think of it? Is it cute? So, what is that? The string of AP4R is replacing 4 with A. Then we got the word upper. According to the Oxford Dictionary, this means a 3-banded armadillo. So this is the reason that AP4's mascot is armadillo. Here is the colored version. He had a bright ruby on his table. And he was born in Japan, so he's wearing in kimono, which is Japanese traditional costume. So his name is Maro. He named after armadillo, and it is well known as traditional Japanese name. So coffee break is down. I will hand out the topic to Shino.
So, return to the main contents. I will explain about lightweight from the 2 points of view, simple API and the flexible system design. Let's focus on each features. First of all, simple API. I'm going to show you the API of how to put messages. For simplicity, I assume that messaging clients are Rails application, and this is an online shopping. In a Rails controller, you can use this API. The arguments are destination, request data, and more options. Isn't it simple? Here is an example code. It's a simple shopping application. There are 2 actions, order and payment. In the order action, you put a message. All you need to do is specifying the destination as an action name, payment, and setting order ID as a request data. That's all. Then we will check out by using this payment action. This action is executed asynchronously in the background. We can get the request data by using a params method as well as normal Rails action. Let's look at the typical message processing flow. This is a typical system configuration. There is a front-end web server as a reverse proxy, and there are some back-end Rails processes. In addition, there is an AP4R process. The front-end web server accepts a request from user and routes it to one of the back-end processes. The back-end process executes an order action and puts a message to the AP4R process. The message is stored by AP4R, strictly speaking, by the reliable message library. Then AP4R process interprets the message and dispatches it back to the web server. The request is routed to the backend process by the web server, and the payment action is executed. So let's move to the next feature, the flexibility of system design. You can configure the system with AP4R in response to requirements and purposes. I will illustrate some configurations. Previous one was typical configuration. There are reverse proxy, Rails, and AP4R processes. Next one, if you have too many messages to handle on one AP4R server, you can distribute the load to multiple AP4R servers, like this. AP4R processes are independent each other. Next one, if you'd like to separate the Rails servers into 2 parts, synchronous and asynchronous, you can handle it by setting the reverse proxy. For example, in this figure, a patch with mod proxy can route requests by URL. A lower right box is Rails process for asynchronous work exclusively. Or you can use URL rewrite filter of AP4R. You can achieve more flexible configuration, including a reverse proxy. With this, asynchronous requests can be processed on any servers you want. In this figure, AP4R uses HTTP to send asynchronous requests by default, the red line. Therefore, they can be processed by any HTTP services. For example, Tomcat, which is a Java servlet container, or anything else. I want to emphasize AP4R's push style here. There are dispatcher threads inside an AP4R process. As you can see, the guy sitting there is a dispatcher. They get messages and dispatch them to consumers, just like Rails application. The consumer are passive. By dispatching with HTTP, we can use well-known load distribution technique, such as reverse proxy. Dispatcher can speak several protocols. Default is HTTP, and others are SOAP, XML RPC, and DRuby. Dispatcher threads can effectively distribute the load by using flow management technique. Suppose there is the situation having two kinds of asynchronous work with very different characteristics. One is busy. There are a large number of messages, but each message takes short time. The other one is heavy, much fewer messages, but takes very long time. By configuring dispatchers, we can manage flow volume properly. We want to separate servers for busy tasks and heavy tasks, and set multiplicity for busy tasks. Here, 10 threads. The message flow with this configuration is like this. Messages of busy tasks go to the upper server group, and messages of heavy tasks go to the lower one. In this second part, we explained about two of the AP4R features, simple API and flexible system design. We are going to show you a demonstration which uses these features. So we will show you a demonstration here. We picked up a shopping store application for the demo. There are two logics, order and payment. For now, we don't use AP4R yet, so everything occurs synchronously. In this application, we assume that the payment logic takes long time because it is very, very complicated. So let's look at the current source code. In the order action, we call the payment method. And in the payment method, we call sleep to emulate the time-consuming logic. To look the response time to users, we use Apache Bench here. First, set up Rails process by Mongrel Rails. Please set up. Okay? And make 10 requests to it. It takes long time. Users may get sleepy. Okay. It takes about 1 second per request. So let's go back to the slide. Let's incorporate AP4R now. At first, a Rails process executes the order action only, and one message is sent to AP4R. Then another Rails process executes the remaining payment action. We set up 3 asynchronous Rails processes in preparation for the heavy payment action. Also, we will monitor the count of messages. We will monitor the count of messages remaining in the AP4R From now, Kiwamu modified the source code on the spot. So in the order action, instead of calling payment method directly, use async to method. Specify action name as payment. Action name as payment. And set request data. Order ID is o.id. And payment action, make it public. And instead of the argument, use the params method to get request parameter. Params method. Okay. And set the response body as true. The dispatcher checks this to confirm the success. So we have finished the job. That's all. We are ready to run the demo. Set up the processes. Restart the Mongrel for synchronous work. And start the Mongrel cluster for asynchronous work. At last, start the AP4R. Let's make requests by the Apache bench. Make 10 requests as before. Oops. Apache bench finished in a second. It's fast. So let's make 100 requests now. 100 requests. The Apache bench has finished already. And to watch messages are steadily processed, let's monitor how many messages stay in the AP4R. The graph shows the temporal transition of the message count in the AP4R. The horizontal axis is the time. The right end is now, and gets older as goes to left. The range is 1 minute. The vertical axis is the message count at the time point. We can see the count is increasing at the startup. The peak is at the time when Apache bench has finished. Then it's decreasing gradually as messages are processed. So one more time, 100 requests. Regardless of remaining messages, synchronous work are processed immediately. Users feels happy. All the messages are properly queued and processed at an easy pace. So we have got through the demo. We saw the improvement in users' response time. And do you feel AP4's lightness? So let's go back to the AP4's advantages. Next subject is robustness. And we will focus on SAF feature here. Now, SAF stands for stored and forward. The purpose of SAF is to ensure the atomicity between application transaction and putting messages. To realize such atomicity, there is a technique of distributed transactions such as two-phase commit. But as you know, two-phase commit is heavy work and we wouldn't like it. SAF is a simple solution instead of two-phase commit. When you use SAF, the flow behind the scene is as shown in the figure. The important point is messages will be once stored in the same database as the application with the same transaction scope. So by committing the application database, the existence of messages is assured. This is the store phase. After that, the messages are really sent to the AP4R server. We call this phase forward. In the demo application, however, message duplication still may occur. In the demo application a little while ago, you should check some unique identifier in the payment action. For example, you may check whether or not the order already has a payment. You can get some information in the book, Enterprise Integration Patterns. SAF is organized as one of the patterns, which is called Guaranteed Delivery. Getting involved with SAF is interesting, but will be a long talk like this. I regretfully skip it now. We will upload the full slides, including these, after this conference, so please take a look at it. We went through the SAF feature in part 4. It ensures the atomicity between application transaction and putting messages. But you should be careful about message duplication. This feature is the basis of AP4R's robustness. I'm going to talk about other 3 features in short. First, you can recover error messages with some trouble happens, when some trouble happens. Second, we support caption recipe in the latest version. Implemented tasks include restarting the AP4R process, updating files from a repository. And the last one is test support. I will explain about it a little more. We provided 2 testing methods, functional test and async test. In the functional test, we use a stub instead of real AP4R process and execute tests quickly. In the async test, we set up Rails and AP4R processes and test it in the circumstance which is fairly close to the real system. Detailed description will be included in the full slides. So, with the combination of functional and async test, you can enjoy benefit of test-driven development even in the application with messaging. So, we have finished all the main contents. Let's sum up them. Finally, in conclusion, 2 advantages of AP4R are lightweight and robust. We have talked about several features of AP4R. AP4R is the messaging library with simple API and simple configuration. It collaborates with Rails seamlessly and provides flexible system design. By using AP4R, we can invoke a synchronous process automatically, and a message delivery is guaranteed by SAF feature. In addition, you can do test-driven development by test support. Future plans are following. We are focusing on smooth operation in version 0.33 series. And for now, inputting messages, we can use only DRuby protocol so far. We want to support STOMP and HTTP protocols additionally. We will enhance monitoring functions in version 0.4 series. We will add some scripts to coordinate with integrated monitoring tools such as Cacti or Zabbix. Also, we think about manipulating many AP4R processes. We are planning to make AP4R applicable in large systems in version 0.5 series. And others in our plan are following. In closing, we would like to thank you all for listening so attentively. Thank you very much.
Do you have any question? Okay.
Have you heard of Twisted?
Sorry?
Have you heard of Twisted? It's a asynchronous, similar thing in Python. Asynchronous process.
He's talking about something called Twisted. It's a Python framework for asynchronous, but I'm not sure Twisted to me seems like this, but that's just my take. This is more traditional messaging queue as far as I took it, but maybe I'm wrong.
I was going to ask if they had any thoughts about the contrast between them.
Yeah. This is a message queue. Yes,
Yeah.
That's basically
Yeah.
what it is. So whereas Twisted more is a framework for building asynchronous servers, this is for actually just queuing up messages. At least that's my take on it.
Yeah. We don't know about Twisted.
Twisted is asynchronous I/O or something. Is it? Twisted is asynchronous I/O or non-blocking I/O framework.
Yes.
But this is message queuing, so it's different category. Please.
You mentioned, I wondered if there was a way in this queuing framework to limit the rate at which messages are forwarded, so that you could, for instance, maintain the load or limit the load on a server.
Yes.
So can you actually limit the forward a message to the AP4R, and then you have instructions that say don't emit more than one of these onto the server in 2 minutes, 3 minutes. So the server doesn't see this sudden flood of messages.
Do you mean such as load
balancing, rate limitation, so you can throttling the width of the gas.
We can control the multiplicity by number of threads of dispatchers. So how many messages are processed concurrently is configured. But do you mean that?
That's part of it. But then if you say you wanted to make sure that server wasn't completely dedicated to messages and could do other work, so you might want to say, I only want to see. Say you have a job that takes 2 minutes to process. You want to see that the messages don't come into the server faster than once every 5 minutes or 2 minutes, so that the server has time to do other things.
Please discuss it later. Thanks. Hi.
Easier question.
Thanks.
The examples you gave were both Rails examples.
Yes.
Is that your primary use case for this? Is it Rails applications, or do you see application outside of Rails for AP4R?
AP4s and dispatchers are not depending on Rails. So
Yeah, we can use AP4R from Ruby of Rails, but using sub-function, it's a little difficult now. But we change AP4R in the future to use just Ruby.
Did you try out some of the other message queues that were out there before writing your own?
message queue such as active messaging.
Things like either that written with the API over the top in Ruby, or I think there's at least one or two other Ruby message queues.
Yes.
I'm just curious if you found them to be lacking something.
we use a reliable message, and AP4R is built on top of reliable message. So this is a messaging library which uses DLB as protocol. So we add the feature of SAF or dispatchers and seamless combination to Rails, easy to use and testing. So reliable message is a very nice library. And active messaging is just client, not server. So it's a little different. Hi. Hi.
Sorry. Okay.
I saw in your presentation you had a moving graph that was graphing the number of jobs. I'd love to have that for other things. I wonder what that was that you were using. You had a graph that was moving along.
Graph?
We had a graph showing the size of the message queue as it was processing the messages.
Yeah.
How did you make that graph?
Maybe you know library graph. Yeah, graph library.
Thank you.
Hi.
Do you have any plans to support?
Sorry, more loudly, please.
Okay. Do you have any plans to support one-to-many messaging?
What?
Do you have any plans to support one-to-many messaging? So sending one message and having multi receivers.
Broadcast.
Like broadcast, like multicast.
Broadcast. We want to reliable message support publish subscribe channel topic, but it's not so easy to use by web client. So one more work is needed. It's okay? Thanks again. Thank you very much.